All right, good morning. We'll go ahead and get started. While you're walking in and getting all set up for class, please log in to Moodle, then Learning Catalytics, and there is the session ID. When I go, you'll be able to see this again once I go back to the Learning Catalytics question, but if you need to know that ID while I am going through the announcements, there it is right there on the board. And so let's just take a minute to go over the announcements. And I'm going to go ahead and join that. So there's that session ID again, and we'll come back there in just a minute. Let's go and talk about the announcements. Learning Catalytics. Again, today is going to be one more test session. If you do have some trouble getting logged on today, the first troubleshooting technique that I'd like you to try is that sometimes students are getting into learning, trying to get in through Moodle, and it's asking you for a username and password. If it does that, try logging completely out of your browser and then going back in and see if that resets it. And if that does not work, go ahead and send me an email with during this class time with your answers, and that it's not pertinent for this class because it's not we're not counting it for credit, but in the future we can go ahead and do that just to make sure that you know you're getting your answers submitted. But it seems to be working for a large majority of you. The homework. So you have a hand-in homework number 2 posted. I'm going to say more about that here in a little bit when I talk to you about StatCrunch. But just plan ahead because I am expecting you to use StatCrunch to answer a lot of those, some of those questions. And that is due this Thursday again in class. And you have some online homework coming up. So Chapter 3, Part 1 is due on Friday. Then when we get a little bit further in the notes, I will also assign a Part 2 of Chapter 3, which will be due on Tuesday. So you have 2 assignments coming up in the next few days for the online assignment. I also want to make you aware when completing an online homework problem, you have the option of completely redoing that problem once. Okay, so let's say that you do a problem incorrectly, then a box is going to pop up and it's going to say, do you want to go on to the next question or do you want to do a similar question? Okay, so you can redo that entire problem once, okay, and then your best grade or the grade that you received most recently will be the grade that gets recorded. Okay, if let's say that you do the homework, you've completed it all, but you got a couple of them wrong, okay, and it's a day or two later or an hour or two later, you can go back, log back in, get to your question as long as it's not overdue, and there will be a button at the bottom right hand of the screen, and it should say try again. Okay, so you can do that one time for each problem. Okay, and within those questions, you have, depending on whether it's numeric or multiple choice, you might have up to 1 to 3 extra tries, within a question. But then you also, in addition, have this option of a similar question. If that's unclear to you at all, please come and talk to me, and I'm happy to explain it to you. Okay, I want this to be a positive experience. I really like the online homework because it gives you this instant feedback. But sometimes the technology side of it can be a little bit frustrating, and I want to make sure to mitigate that frustration just so that it's a positive learning experience for you. So please do see me if you're having trouble with any of those things. Okay, so there are some things that we want to address with the homework assignments that were handed in on Thursday, and you'll of course see your graded work this coming Thursday, but just a couple of points to make so that it can help you as you're constructing the next homework assignment that you're going to turn in. Okay, make sure to label all axes and graphs on the graphs clearly. I think I've already talked about this, but this is just really important so that you can communicate to your reader what is going on with your data, right? Without labeling those axes, a lot of graphs are just going to be pointless. Okay, keep levels of categorical variables in their natural order. Okay, so if there is a natural ordering to a variable, then try and keep them in that order so that it makes more sense when you're analyzing the results. Making sure to round properly. Okay, so if you calculate this proportion in decimal form and you get this in your calculator, rounding to 3 decimal places, see this, if you have a value that is 5 or greater, right, next to the, you're carrying to the 3 decimal places. We're not dealing with significant digits in this class. We're just talking about how many decimal places do we want to keep. If we want to keep 3 decimal places, okay, that the next value up from the 7 is a 5. That means that we're going to round this up to an 8, right? So if that's unclear, if this would have been a 0 through 4, I would have kept that at a 7, right? So hopefully that's pretty straightforward. Make sure to show calculations if we say show your work. And relationships are between variables, not the levels of a variable. So if we ask you to describe the relationship between the lighting variable and the sight variable, right, then you don't want to talk about the relationship between nearsightedness and room light, okay? You can talk about the proportions within there, but it doesn't make sense to talk about the relationship between the actual categories within those variables. So you could certainly say, oh, within those who used, who had a room light, this is the breakdown of that of the sight variable, and that's completely acceptable. But just be careful not to talk about the relationship between categories. It's the relationship between the variables. Okay? And also, this is going to be something that we're really going to hammer in later in the course, so you might as well start thinking about it now. A lot of times we're trying to learn about a big population based on a sample. Okay? And in the homework example, we had 479 children, and they were the sample that we were studying. But the population that we were after, right, is really, all children between the ages of 2 and 16. We're trying to make an inference on all children based on these 479 children. Okay, so just try and keep that straight for yourself. We're going to be identifying the sample and the population a lot here. Okay. Last point, and then we'll get started with some material. Define the variables very clearly. Okay, so there was the first problem on the homework assignment talked about these owl nests. Okay, and one of the variables was whether or not the nest was in 100 yards of water. Okay, and that's a binary variable. If you just said nest within 100 yards of water, that doesn't tell us if you realize what is actually being recorded. Okay, if you just put a yes, no at the end of it, that would be awesome. Okay, that's telling us, yes, that's a binary variable. But if you're just listing that without saying whether or not, that's not clear to us that you understand what variable is actually being recorded. So just be careful with your wording there, okay? All right. 2 quick announcements. Exam 1 coming up October 6th. That's still a couple of weeks away, but I just want you to get that in your schedule so you're not planning a trip or work. However, if you think you have a conflict that is not going to be movable, please contact me as soon as you can so that I can, converse with you and we can figure out if, what we should do about that. Also, I've already made this announcement, but I just want to make you aware because this is not the same as the final schedule, that this is when our final exam is scheduled, Friday, December 16th. Okay, so just put that in your notes. This is also up on Moodle, but put that in your calendar as well. Okay? All right. So I'm going to start off with a little quiz. And again, this is not for credit, where this is our last trial. We'll start doing learning catalytics for credit on Wednesday. But I want to start off with a quick little question here. So let's go ahead and move to learning catalytics. Okay. So we have a hard time weighing bears in the woods, right? So we oftentimes try and figure out if there are any other variables we can use to predict a bear's weight. So researchers caught and measured 54 bears, recording their weight, neck size, length, and sex. Which of the following would be a legitimate way to visualize the weight variable? So which of these is a legitimate way to visualize that weight variable? So even if you don't have a device in front of you, please just answer this for yourself in your head. Otherwise, go ahead and submit that answer, and then we'll talk about the results. If you're unsure, it's okay to talk to a neighbor. It's okay and encouraged to look in your notes. Okay, so I just have about 20 students left to answer. I'm going to go ahead and stop this in about 10 seconds, so go ahead and get your answer in. Give it your best shot, and then we'll talk about it. Okay, so I'm going to stop the delivery here. And I'm not going to lie, I'm a little heartbroken here. Okay, so let's show the results. Okay, so we have about 50% of us who said a histogram. I was hoping that would be a lot higher. Okay, but remember, we just finished histograms on Friday, and histograms are for displaying quantitative variables. Okay, so pie charts, bar charts, segmented bar charts are all for displaying categorical variables. Okay? Okay? All right, so then E, of course, is out of the picture. And so now we're left with B. That's what we're focusing on, this histogram. So that's where we left off, and so that's where I'm going to start in the notes right now. Okay? All right. We left off on page 23. Okay, so we introduced a histogram last time with those the Old Faithful data. Okay, we defined what a histogram is actually displaying, and if you're a little foggy on that, then you need to go back and read about histograms in the text. And now we have an example of a histogram that is maybe not so, not acceptable at all, okay? So let's go ahead and look at this example, and then we're going to point out the things that are missing, and then we're going to correct that histogram, okay? So here are some, the lengths of English-British rulers' reigns in years, beginning with William the Conqueror, okay? And we have a few here, so I'll just kind of point out. So each of these are the lengths of reigns, okay? Each of these counts, and they're listed in order for us. And right now we have Elizabeth II, whose reign is at 64 years. She's the current, okay, for the UK. And we also have this 63 is Queen Victoria. And this was 1837 to 1901. Not that you need to know these dates, but it's kind of nice to put some names to these numbers, okay? And this 59 is George III, the UK, and this is 1760 to 1820. So just a couple of names to put on there. Okay, this ruler, I was trying to research this morning, and there were a couple that actually did not make it to their first year, but the one that I think is associated with this number, we believe was actually ousted before we could actually have his first year of his reign, so within 8 months or so. But let's go ahead and take these numbers and see what we want to do with them to display them visually. Okay, so remember that a histogram, we're going to use bars to represent the frequency with which, these reign lengths occur. Okay, within each like bin width, essentially, that we're choosing. Okay, so that means that there were 7 different reigns that were between this 0 and, let's say, 8, right? So 1, 2, 3, 4, 5, 6, 7. And then that's the next one, 7, goes into this. So this must be 7 here. Or 7, because then the 7 goes into the next highest bin. Okay? So that's what that is representing. Okay, but based on our discussion last Friday, what do you see that is wrong with this histogram? There are 4 things that I want to point out to you that are incorrect. Yeah? The fact that, that these bin widths aren't the same. Okay, so we'll say the first thing is unequal bin widths. That's the most striking error to pop out of there. What else? Yeah. So in this, what's that? Yeah, so in this case, that's okay. The histogram is kind of binning these data just so that we can visualize them better. Yeah. Exactly, yeah. So we definitely want our bars to be touching. That's not to say that we can't have gaps. Okay, so you're going to notice in your histograms that you're creating for your homework that you may have some gaps there. Okay, and that's due to like a really unusual value out here. You can have a gap, but in general, you really want them to be minimal. Okay, and the basic idea is that you have those bars touching to illustrate that that's a continuous variable. So number 2, we'll just say, too many gaps. But I just wanted to make that point that you can have a couple of gaps in a histogram, that doesn't make it incorrect. Okay? You want this, no matter what bin width you choose, you want this scale to be, exactly correct in terms of its spacing. Okay? What else? What else do you notice? Yeah?
Relative frequency.
Yeah, thank you. So relative frequency, that's not relative frequency, right? That's just frequency. So that should be frequency. So relative frequency label is incorrect. Okay, what else? Yeah? Yeah, the x-axis isn't labeled at all, so we don't know what that's even representing. Okay? Okay, so those are all the main things that are wrong with that histogram. So now, if we put that new histogram up, okay, hopefully you are able to, be able to see what's going on with those data, okay, and understand where that histogram is coming from. Okay, and so there's that nice histogram. The bins have the same width. The x-axis is there. We've now replaced relative frequency with frequency, and that's all I'm going to say about that. StatCrunch does a nice job of choosing the bin widths for you, but you're welcome to play around with those. And in fact, I ask you to do that on the homework assignment just so that you can kind of see what's going on with those different bin widths. So with that, I'm just going to quickly show you a couple of things in StatCrunch. And that way you are all good to go with doing that for your homework assignment. Okay, so again, I think I've showed you this a few times. But you go to this StatCrunch website and you go to open StatCrunch, and then you can download that data from Moodle, download it anywhere, then you go to data, load data from file on my computer, right? And then you're going to choose file, and there's my lab data that I wanted to show you today. Okay, so just in the interest of time, I'm going to just go back to this guy here. But hopefully that should be pretty straightforward for you. Okay, then I'm going to go to graph, histogram, and I want to show you the variable. So on the first day, or the first lab, which was over a week ago now, you told me how many states you had visited. Okay, and so I want to show you what the histogram looks like. So if I leave all of this stuff as the default, okay, and just hit compute, this is what it gives me. Okay, so this is a nice histogram. Tells me that, gives me the variable name down below, tells me that it's in frequency. But then I can also say, okay, well, what if I want to, instead of a bin width of 5 states, let's say I want a bin width of 10 states. What is that going to look like? Okay, and I can compute that. And, I personally feel like that doesn't give me as much information, right? It's kind of, it's not as informative to me as that bin width of 5. Let's see what happens if I change that bin width to 2. Okay, well, that's not really that bad, really. Okay, the bin width of 5 is nice, but this one is just fine as well. Okay, it gives me quite a bit of detail. Okay, and I see that the bulk of students, right, quite a few students have visited, say, between 10 and 20 states. And then there's kind of this, there's a little bit of another mode here between 20 and 30. And then really after 30, it starts to kind of, even out here. And not very many students have been above those 30 states, okay? So you can kind of see what's going on there. And we'll talk more about what we look for in the shape of this histogram today and tomorrow, okay? Then what you're going to do, let's say that you create this graph, okay? And you're going to copy it. Then this little image says, okay, here's what you need to do. You need to right-click on the image and select copy, then paste into Word using Control-Alt-V, and the paste as device-independent bitmap. So this is, you want to make sure to read those instructions. So I'm going to right-click and I'm going to copy. Then I have my homework assignment here that you all download from Moodle. Okay, and I'm just going to Control-Alt-V. And then it says, well, what do you want? And I want to do device-independent bitmap. Don't ask me what that means, but it works. So there we go. Okay? And so then you can grab on the corners. Don't grab on the sides because it'll distort the image. You can grab the corners and size it down so that it fits there nicely into that document. Okay? Is that okay with everyone? All right, very good. Okay, that's all I want to show you with StatCrunch. So let's go back and now talk about dot plots. So again, now you've learned from that bare learning catalytics problem that histograms are for displaying what kind of variable? Quantitative variables. And that's the most common display that you're going to see. But there are also a couple of other displays that we use specifically for smaller data sets usually, and we're going to investigate those right now. Yeah, question? Yeah, so the information from the survey is on Moodle, and it's there's a section called data, and it should be right up there for you. And if you have trouble finding that, don't hesitate to send me an email. Yeah. Okay, back to our notes here. Okay, so the next thing that we want to talk about is dot plots. Okay, so we're going to look at some home run data here for the next, we have a couple of examples where we're going to look at home run data. And baseball data, they are natural for learning statistics because there's so many interesting variables we can collect on what's going on in baseball. So we'll try not to do too much and give us some variety, but there are a few examples where we're going to look at some baseball variables. So here we're looking at the number of home runs hit each season by Barry Bonds over 22 seasons. Okay, and like I said, we're going to learn how to construct a dot plot, and this is super straightforward. Okay, and I'm not going to even describe it in words. I'm just going to show you what it is, and then I have a home run number for each case, right, for each season. And I'm just going to make a dot representing each season. So I see the first season was 16 home runs. So I'm just going to go here, make a dot at 16. Okay, so you can even do this independently of me and just make sure and just do it yourself. It's just a really quick way of visualizing your data. Don't need any technology. I sure did. Thank you. Thank you for that. And that's something impossible for me to correct on there, isn't it? It's my black felt tip marker. So note that 44 is not supposed to be there. Thank you. Any questions there? All right, so this is just a beautiful way to look at what's going on with your variable, okay? It's just a small number of observations, quick way to just visualize your data, okay? All of the values are pretty much preserved except for my incorrect 44, right? I can see exactly what values are being displayed, essentially, okay? So I'm not losing any information. As I was with the histogram, I really am losing those exact data values, okay? So just keep in mind, I want you to be able to tell me, what are all possible displays for quantitative variables, and then which ones are more sought after, I guess, or are going to be more useful for small versus larger data sets. Okay, so these guys are great for small data sets. Okay, I don't want to sit there and make a dot plot by hand for 10,000 data values. And it's also, even if I just make it with a computer, it's going to be harder to read if I have that many data values, with a dot plot versus a histogram. It's not going to give me as much of a benefit. Okay, you can see these unusually low and high values very easily. So that 73 automatically pops out for us, right? Whereas we might not have realized how far away that 73 was from the bulk of the data until we actually looked at a picture, okay, about how unusual that 73 really is. And also that 5 down there, right? So it turns out that he was injured for part of the season for the year that he had those 5 home runs, so that's telling us something about that. And then some of us might have some ideas about what happened during that 73 year as well. So, okay. And let's see here. We're also going to really be focusing on statistics is really this the study and understanding of variability, okay? And we can really get a feel for how variable his seasons are in terms of the number of home runs from season to season. How much do they change from season to season? And we're going to say a lot more about that in the next couple of days as well, this idea of variability, okay? So what can we say about the Barry Bonds home run totals? So we're going to start, learning how to make these descriptions. And I might ask you to hold off on making your description for the homework assignment until after Wednesday's class, just because I'm going to give you a lot of explanations. You can do everything else, but just that description of the histogram I'd like you to hold off on. But here I can say this. Right now, without having any measures of what we're going to talk about, center and spread, we can say that the Bonds home run totals, okay, they ranged from 5 to 73. Okay, and here I'm using range as a verb, okay, and I'm going to talk to you about that later when we define range as a statistic, so just be careful how you use it. But this distribution ranged from 5 to 73 home runs, with the most typical seasons and this is more of just a visual picking off. I'm not grabbing these values for any particular reason other than they're nice and easy values to pick off, and I believe that most of those home runs are occurring between 25 and 45 home runs per season. Okay, I would say that grabs the bulk of that distribution. Okay, just to kind of summarize that for your reader. So most typical seasons are ranging from 25 to 45 home runs. Okay, and then, we can point out that the seasons with the 5 and the 73 home runs were very unusual. Okay. Okay. All right, so I want to point out really quickly that this is our first crack at describing a distribution. Okay, and we're going to add in a lot more detail once we get some summary statistics such as, measures of center, measures of spread, and that's where we're headed over the next couple of days. So I just want to make you aware, you might want to make a note of this, that this is not the proper description that I'm asking for until we actually insert those numerical summaries that I'd like to introduce to you. Okay? Okay, so dot plot. Dot plot is for only representing a quantitative or categorical variable. Leaf display. Okay, so we're going to look at the same data for the Bonds home run totals. Okay? So this is sometimes referred to as a stem and leaf display. It's sometimes referred to as a stem plot. Okay? And it doesn't matter which one you call it. This, instead of just giving those dots on a number line, this actually gives you the values within the display. Okay? And you're asked to create one of these in your homework assignment as well. So what you do is you first create what's called the stem, okay? And here we're going to say that when we give it this little key, you always want to show a key with your stem and leaf display, telling exactly what each value represents. So I'm going to have the stem, okay, which is representing the first digit in each of these numbers. Okay, and then all of the leaves are going to represent the second digit in all of the numbers. Okay, so for instance, 3 line 4 represents 34 home runs. Okay, and so your book will often display these from lowest to greatest, bottom to top. And I'm going to show you why I prefer to do the other way. Okay, but let's just do this. So we're going to represent all of the possible values for the first digit. We have the numbers 0 through 7 here. Okay? And I'm just going to go through and I'm going to draw in each number next to, as the leaf, right next to the stem. Okay, so this 16, I put in a 6 right next to the 1. Then the 25, so 2, 5. Then 24. So now I'm right next to that 2, so I'm going to put a 4 there. Okay, so you try to be very neat with these, making the numbers the exact same size as much as possible. Okay, so that they give you a valid perspective on exactly where the data are falling in the distribution. Okay, the number 33, let me know if I make any errors like the dot plot. 25, 34, 46, and so on. I'll stop calling them out. You get the idea. Notice how I have each of these are really lining up in columns, and the rows are nice and neat as well. All right, there is that beautiful stem and leaf display. Okay, so notice that, this is fine how it is, but, we always like to make things look as pretty and easy to read as possible. So the next step that we like to do, and the computer programs will do this for us as well, is to just reorder all of the leaves. Okay, so I'm just going to do the same thing. I'm just going to reorder everything. So this is going to be 5. Again, this is going to be 6 and 9. Okay, but now I'm going to have 4, 5, 5, 6, 8. Okay, here I'm going to have 3, 3, 4, 4, 7, 7. Okay, then I have 0, 2, 5, 5, 6, 6, 9. Okay, and then of course that 73, which still shows up as an outlier. Or I shouldn't say outlier because it's actually not. We'll define that here, but an unusual value is showing up for us on that display. Okay? So these look a lot different, right? The dot plot versus the stem and leaf display. They're displaying the exact same distribution, but they look quite a bit different. Okay? And so just keep that in mind that you could have a lot of different displays that, they look different depending on, say, your histogram with the bin widths. Okay? Dot plot versus a stem and leaf display. Okay? And so some of this is just going to be subjective in terms of which one you think is really displaying your data the best. Okay? Let me show you why I like to do the ordering from smallest to greatest. It's because if you turn this page on its side, notice that the values are from smallest to greatest, just like a histogram. Okay? And just like the number line, right, from a dot plot. So it's much easier to talk about the relationship, right, and maybe you're kind of looking at it like that, right? And so we're going to be training our brains to think about distributions in terms of the smallest values are on the left, the largest values are on the right. So if you make the distribution go from greatest to smallest, then it's a little bit harder to visualize. So just that's the reason why I like to do it that way. Okay. A couple of notes. It's not necessary to include decimals within the stem plot. So, we'll come up with another example here, or you have examples in your homework where you're asked to do this, and we lead you through a different way of constructing these guys. Okay, so for example, if our data values had been 1.6, 2.5, 2.4, etc., then the stem plot would look the same. Okay, so you could say 3-4 would represent that 3.4. Okay, and sometimes if you have the number, say 3.45, we might leave off that last digit just for display purposes, and then you would note that in your key. Okay. Again, I already made these 2 points, so I'm not going to talk about them again. They just talk about the spacing and the ordering of those leaves. Okay. Let's see here. So let's go ahead and point out the main benefits and disadvantages of histogram, dot plot, and stem plot. Okay, so I've tried to talk to you about them already, but let's just write them down so you have them for yourself in your notes. Okay, so what are the advantages and disadvantages of a histogram? Okay, so again, histograms are the most common display you're going to see. They're very useful for large data. Okay. Histograms is that when you're binning those values, you lose a lot of the actual those numerical values, right? So you don't actually know what those data looked like. Okay, you know generally what bin they fell in, but you don't know the exact values. So you lose some of that information. Okay, it's not to say that you've thrown it away, that you've erased it, but just for that display, you're not able to see that. So we'll just say, but they don't retain the actual data values. Okay. Okay, so again, just reiterate, dot plots and stem plots are nice for small data sets. Okay, they are easy to construct. And they retain the actual data values. Okay, any questions about that? Okay. All right. Which leads us to one of the things when we're going to be really focusing on describing distributions over the next couple of days. The first thing I'm going to ask you to tell me about when you're describing a distribution of a quantitative variable is the shape of that distribution. Okay, so there are some different things that we are going to think about when we're looking at the shape. The first one is the number of modes. Okay, a histogram that has one peak is going to be called unimodal. A histogram with two peaks is going to be bimodal. And a histogram that does not have a distinct peak in which all the bars are pretty much the similar site is going to be called uniform, or the similar height is going to be called uniform. Okay, so this is unimodal, right? And there are different variations on that, but just a single hump, right? This is bimodal, and this is sometimes subjective, whether you think that dip is enough of a dip to warrant calling it bimodal. So that's going to be a subjective term sometimes. Okay, and then we also have uniform, okay, where essentially, you might have some variation, but generally, there's just this uniform distribution across all values of your variable. Okay?
Are there any disadvantages to dot plots and stem plots? Sorry to go back.
The disadvantages are just that they're not as good for big data sets because they're just hard to look at for bigger data sets. And you don't want to construct them by hand. Let's see here. So then the skewness, a unimodal distribution is either going to be, so we're back to this unimodal up here, okay? We're either going to have symmetric, okay? So if it's unimodal and symmetric, it's going to look something like that. Okay, if it's skewed to the right, that means that the bulk of the data is going to be on the left with the smaller values, and then there are going to be some observations that had really high cases, or some cases that had really high values. Okay, so this is one that always confuses people because they think that they want to say that this is skewed to the left because the bulk of the data is on the left, but you're really talking about where the skewness is. So think of this, where the skewness is, that's skewed to the right. Okay, and then last we have distributions just in the opposite that are skewed to the left. Okay? So, when we start, we're not done yet. We're going to go back to learning catalytics. Go ahead and wake up your devices. When we start on Wednesday, I'm going to kind of just point out some different times when you might expect to see a skewed right distribution and other scenarios where you might expect to see a left skewed distribution. Okay? But let's go ahead and show you this last variable here. Okay. Okay, so I'm showing you this distribution. This is the number of states visited variable. And I want you to tell me what is the shape that best describes this histogram. Is it symmetric, bimodal, skewed to the left, skewed to the right, or uniform, based on what we just learned? Okay, so as you are reading, please do start reading about measures of center, measures of spread, and make sure that you're understanding exactly what a histogram is displaying. Please go ahead and get your answer in. I have about 20 people left to submit that, and then I'll reveal what the answer is. And why don't you just, as a general rule, let's just wait to start packing up until we because I'll usually do a question right at the end. We have about 30 more seconds. Let me go ahead and stop that one, and then I'll talk about it. Not that I need to say much about it. I'll just show you that most of you chose D, which is skewed to the right, so that's a skewed right distribution. I'll see you on Wednesday. Have a lovely day. Thanks. Yeah. Oh, I need to stop this really quickly though, because I forget. I'm just going to do this real quick. Stop.